What's up, Bobby? How's baseball going? I guess not here.
I think he's not there yet. Oh,
hello, everyone.
No baseball chat.
It's just out in the back.
Okay.
Let's see how many people are here.
How's your Korean baseball watching going?
I haven't seen that in a while. I just lost interest. A big email from our school district today saying basically nothing.
Oh.
Well, we have these options and we want to hear from you.
Oh.
Yeah. So till there's a vaccine, I don't think anybody doing anything.
Yeah, just hanging out.
Yep. All right, so the test. How was that for you?
Horrible.
Horrible?
Number 10 took me a while to figure out that it was an ellipse. I had to go eat. Then I came back, rewrote it because I didn't like the way I rewrote it on my laptop. And then once I put A over sine, I was like, oh, it's, all I have to do is just square both of them.
Okay, so number 10, I'm just real curious to see what you guys did. That problem doesn't have an antiderivative. It's called an elliptic integral. And because I know you guys are putting this stuff in software packages, I kind of wanted to, see how that one went. Obviously, I'm not going to grade it. All right, but at the end of class today, I'll take you through it. That's the second page. So
that's how much work it should have taken to do that whole problem.
yeah, but
I didn't get it right then. Oh man.
Well, I'm not grading it. Because I know that you guys are looking and getting together. I just wanted to see what's out there because I do remember in the old math packages, you would put them in like in Mathematica and it would say error type 1 elliptic integral.
You can't put that one in anywhere. Doesn't work.
It should give you an elliptic integral message.
I'll be the honest guy. It doesn't. So just comes up with an error.
Well, that just means you're in the wrong software package.
Yeah.
Because I had a student a few years back that he came in with his laptop and he said, I don't get this. What does this message mean? Error type 1 elliptic integral. So it's in whatever he was using. Okay. Let's share the screen here. All right. And there we are. Here's what we were doing this morning in Math 30. All right, so today we're actually in pretty good time-wise. This is the end of week 4 tomorrow, right?
Yeah.
Yep. 185. Conic sections. Okay. And I got to turn this thing over. Okay, so we are once again going to go through these conic sections. So pretty much all these calculus textbooks are conic section crazy. But where they come from is you take a couple cones like this and you start like taking slices of it. And so if you slice this thing sideways and looked at what the resulting thing that you would get what's called an ellipse. Okay. And if you were to slice it like this, take out the thing, you would get an ellipse.
Hey, what section of the book is this, Bobby? Is it 10.5?
10.5.
Thanks.
Parabola. And if you cut it like this and spit out what you would have these two pieces. And this is what we call a hyperbola. All right. Are you done? Turn the music up. No, it's just kind of loud because the window's open. Okay, so what we want to do is, see how we can generate some of these things. All right, so we'll start with the classic definitions of what these are. Okay, so we'll start with parabolas. All right, so let's let F be a fixed point. It's called the focus. And let's let, a lot of times the book uses D, be a fixed line where F is not on D. D is called the directrix. Okay, so the definition of a parabola goes like this. A set of all points P in the plane, such that the distance from P to F equals the distance from P to D is called a parabola. Okay. Okay, so we can generate one of these things, like for example, let's suppose that the fixed point F is at 0, P, and the line D is going to be given by y equals negative P, where P is a positive number. Okay, so here's our XY grid. And here's this point where it's an F. And this is the negative P value. And this is that line. Having fun with these colors. Okay. All right. So now just by kind of eyeballing this, because this has coordinates P comma 0, isn't this point on the parabola? Doesn't it satisfy the distance thing?
Yes.
It does, right? Okay. So that's a point that's going to be on the guy. Okay, now if we were going to have another point, let's say this is the point X comma Y. If this is going to be on the parabola, then let's call this the point Q, okay, then the distance from the focus to Q must equal the distance from Q to the line D. Okay, well, that's easy enough because the line Q to D, the distance is P plus Y. By the way, for this focus, the most common letter used is P, but there are also sometimes books that use A, okay? As far as the distance between the focus and the other guy, we just use oops, this was wrong. Got that backwards. That's 0, comma, P, okay? So it's the difference in the x's squared. So that's going to be x squared plus y minus p squared is equal to y plus p. Okay, now I'm just trying to get a working equation here. I'm not solving for anything. So I'm going to square both sides to get x squared plus y minus p squared equals y plus p squared. All right, so now this is going to go x squared plus y squared minus 2py plus p squared is equal to y squared plus 2py plus p squared. And we see that there's p squared on this side, p squared on that side, so they cancel. The y squareds are going to cancel. If I move this to the other side, we get our first formula, x squared equals 4py. And this would be a parabola that would look something like that. Okay, now the reason that we're not writing y equals like what you're accustomed to writing, 1 over 4p x squared, is because of this p. We're now in the business of wanting to identify it, okay? Okay, and so this guy, let me erase this junk right here, okay? This guy has the focus at the point 0, comma p. Now, without deriving this, we would get x squared equals negative 4py if we flip-flop the focus and the directrix. Okay? If the focus is on the x-axis, we're going to get y squared equals 4px. And now this is the focus at the point p, comma 0. And number 4, y squared equals negative 4px. Okay? And this now has the focus at negative p, comma 0.
What was the focus? So the focus on the x-axis was 3. Focus on the y-axis is 1 and 2.
1 and 2, the focus is on the y-axis. 3 and 4, the focus is on the x-axis.
Cool. Perfect. Thank you.
Okay. All right. And so like you draw a little picture here of this guy, you know, this would be going up. And then this one would be going down. This one is going to go sideways like that. And this one's going to go sideways like that. Okay. Now, in all of these cases of the above, the point V which is 0, 0, is on all parabolas. Now, there's many ways that we can characterize what the vertex is, but in general, V equals the point on the parabola so 0, 0 is the point on the parabola which is closest to F, the focus. So as you see here, if that's where the focus is, when you start moving away from it, the distance is going to become greater and greater. Okay. All right. So V is called the vertex. And when you write it standard form back in, Algebra 1 and Algebra 2, you memorize negative B over 2A. That's the X coordinate of the focus. And then you just shove that number in, you get the Y coordinate. So if we want to move the vertex V to, let's say, HK, then if you remember, okay, now I'm asking a few of you to go back to pre-calc with me. But do you remember that if you were to graph Y equals F of X minus H, that this is a sideways shift of the graph? And if you subtract K from the Y, it is an up and down shift. Okay, so for all of those 4 above equations, we'll just do that. So if the vertex is at the point H comma K, then what we have is one of them, X minus H squared equals 4P Y minus K. Number 2, we'll have X minus H squared equals negative 4P Y minus K. And then for the sideways ones, we're going to have Y minus K squared equaling 4P X minus H. And then the fourth one is going to be Y minus K squared equals negative 4P X minus H. Okay. Okay, so let's do an example where we have this equation. Let's say y squared plus 4x squared plus 4x minus, no, not this one. Don't want to do that one yet. Do this one. Okay, where we've got y squared plus 2 equals 3x well, I guess I don't need y squared plus, control with that pencil, plus 3x minus 2 equals 0. Okay, so what you do, anytime you recognize that one of the variables is squared, it's always a parabola. And it's going to open in the direction of the non-squared variable, okay? So this guy is going to be a side-to-side parabola. Okay, so what I want to do is I want to find the vertex and the focus for this guy. Okay, so when I move this to the other side of the equation, I'm going to get a negative 3x plus 2. Okay. Okay, so I need to factor a 4 out of that. Okay, so 4, then this would have to be 3 over 4 to get back to negative 3, right?
Yeah.
Yeah, okay. And then minus 1/2. Forgot the x. Okay, let me start that over. This is a one we want to make sure we get right. Okay, so the y squared, I'm going to factor I'll factor the negative 4 out of the whole thing. Okay, so what I'm left with is going to be 3 over 4x, and then minus 1/2. Okay, now this is the form that we're trying to get it in, that thing above. Okay, so now what? Another thing you could try would be this. You factor the 3 out. I'm just playing around here now. Okay, so negative 3, then it's going to be times x minus 2/3. There we go. Minus 2/3. Okay, so now we know where the vertex is. The vertex is at 2/3, comma 0, because this is y minus 0 squared. Okay, now if I multiply negative 4, then this has to be 3/4 to get x minus 2/3. Okay, so the p is 3 over 4. Okay, now to find the coordinates of the focus, do a visual illustration here. Here would be the vertex. Okay. And we know, because it's y squared equaling negative 4p whatever, that this is a sideways parabola that's going to open this way. Okay. The focus is always inside the parabola. So by blowing up this little number line thing here, like this. So if this is where we're at, h0, then the focus is going to be this h minus p, comma 0. Okay. And so the h is 2/3. So the focus is at the 2/3 thirds minus 3/4, comma 0. And that is 8 minus 9 over 12, negative 1 over 12, comma 0. Okay. In the exercises, he has all kinds of these puzzles where he gives you some information and then he wants you to go with it. So like, let's say, I'll just make my own problem up. Let's find the parabola
Professor, I have a question. From where you got the 3/4 and the last in the last question, the 3/4? Yeah, from where you got it?
Okay, so the standard form has a 4 out in front.
Yeah.
So I needed to start with this and then factor a 4 out. And I factored the 4 out like that.
Okay.
So when we do that problem, we're always going to have to factor a 4 out of that thing?
If you want to read off what P is, yes.
Okay.
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 So I'll give you this information. Ready? So the parabola has the focus at the point 3, 6, and it has its vertex at the point 3, 2. Okay, so drawing a picture real quick here. The vertex is at 3, 2. So here's like, let's say 3, and here's 2. Okay, so that's where the vertex is, and the focus is up here. Okay, so now we know that we are dealing with an up and down parabola that opens up. So that means that the equation that we're interested in extracting is x squared minus h, x minus h squared equals 4p y minus k. Okay, now pretty much most of the information is there. Okay, it's going to be x minus 2 squared equals 4p times y. This is supposed to be a 3y minus 2. No, I had it right the first time, didn't I? X
So
minus,
it's x minus 3, y minus 2. Okay, that makes sense.
yeah, there we go. So we still got to figure out this p. Well, remember that the distance from the focus to the vertex is p. So how far is it from here to here? 4, right? And so our x minus 3 squared equals 16 y minus 2, or you can say 4 times 4 y minus 2, depending on if you want to keep track of the information like that or not. Okay.
So just for the sake of, I know we can use the computer and all that jazz, but just for the sake of like trying to figure out how to do these on the test, can you like put something similar to this or something kind of like this idea so we know, oh, hey, we've done this before? You don't have to do it on the next test, just like
these problems, like what I've been doing?
Yes. Something that's like, oh, hey, I know how to do this, so I can go through the problems. I mean, it may be too easy, but I got.
Well, I'm just kind of looking at the exercises and I'm changing some numbers on a couple of them. Some of them using the same numbers. But yeah, I mean,
this is crazy easy. I don't know if this is what this section is, but this thing you just showed us is like not even 5 lines. So it's crazy.
Okay, yeah, but things are going to get a little more challenging as we go because the parabola is Okay, now before we finish with parabolas, let's say I've got some parabola sitting over here like this. It's a pretty weak parabola. It's sitting out somewhere, okay? Something like that. Now the focus is this point right here, somewhere inside it. The focus, and this, you get into like junior level physics, and you perhaps might solve this problem. If this is the line, which is called the axis of symmetry, which goes through the focus and the vertex, okay, then if you were to shoot a BB parallel to that line, angle of incidence equals angle of reflection. And even though I didn't draw that very well, maybe I'll move the focus. Move the focus. Oh, wait. Didn't want that. I'll move the focus to here. Okay. And then here is this axis of symmetry. So it turns out that what happens is these things will ricochet off no matter where they hit, and they will bounce right back to that point. Okay, even these guys will go boom, 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 boom. So there are many shapes that look like parabolas, but the main thing about a parabola is that it enjoys that property where everything kind of collects up. Okay, so can you think of an application for this?
Like a bowl? I don't know.
Well, let's see. What do you see on the roofs of most apartment complexes and stuff?
Oh,
You
satellite
see-
dish.
Solar panel.
Oh,
Yeah,
solar panel.
this is what it said. This is how satellite dishes are made. So
Okay.
next semester, what you're going to do in Math 280, for you guys that are going to 280, you're going to look at the three-dimensional conics, and they're called, so the three-dimensional version of a parabola is going to be called a paraboloid, okay? And these guys also have a focus, all right? And the way that you do this is that you have these little boxes. Now you know where these things are located, right? The collector is located, is located right at the focus. Okay, now if you want better signal, like let's say, you know, the people that discovered that the background radiation of the universe was not evenly distributed, they had this big old boxy looking thing where the focus is like way back in here inside. Okay. Now, technically, you can make a satellite dish any size you want. As long as I got that thing there and I have enough to attach it, you know, I could even do something like this. Where I have this much satellite dish, and then I'll put a big old ugly looking thing here, and I'll have more material than I'll have dish. It's still going to collect up stuff, but it's not going to, it's not going to be as fruitful as this guy right here. Back when I was in high school, I watched an episode of MacGyver where out of gum wrapper, he fastened himself a perfect paraboloid, which then he pointed at the sun, and he put this piece of cloth right where he thinks the focus is, and then he caught that on fire, and he was able to use that to activate a laser to get inside the mountain. Okay, so it's pretty far-fetched, but it was kind of sound math that, you know, just don't believe that he could actually do that. Okay, so
applied physics, right?
what's up?
Applied physics. That show is a lot of physics.
Yeah.
I love it. It's on Netflix.
If you've got Yeah, if you got access to those old MacGyvers, they're pretty good. Okay, so a couple other things here before we leave these guys. So the focus is going to be some point. Now remember, the focus is not on the parabola. It's like inside it. Okay. Now the line that goes through the parabola, goes through the focus, which is perpendicular to the axis of symmetry. Okay, this line has an unfortunate name. It's called the lattice rectum. Okay. And I would imagine when engineers are designing satellite dishes and keeping costs down, there's always this, okay, well, how far below the lattice rectum do you want us to cut? Like, should we do it from here to there, and then we'll attach the thing like here? And then there's probably some principles in engineering that I'm just not aware of that tell them what to do. But in any event, that's that. All right, well, the next conic section that we want to look at is the ellipse. Okay, now the definition of ellipse is we have, let's let F1 and F2 be two fixed points. They are called the foci, or the focuses. All right. So the set of points P such that the sum of these two distances is equal to a constant is called an ellipse. Okay. All right. So we'll do the standard thing here. I'll try to use the same letters that your book's using. He is using for the ellipse, he is using the letter C. So I'll be using the letter C too. Okay, so for the grind it out part, let's suppose that F1 is at negative C, comma 0, and let's suppose that F2 is at C, comma 0. Okay, so over here I've got this grid. Okay, and so here's this F1, and then here is the F2. Okay, now the set of points P such that this distance plus this distance is a constant. That's what we're after. Okay, so let's kind of go through this. Let's say that that was XY, and then this is negative C0, and this is C0. And I can remember in elementary school having little pieces of cardboard where you stuck tacks in, and then you put a loop around something, and then you pulled tight with your pencil or whatever, and it would draw out an ellipse. I guess back when the school districts had money. Okay, so let's let the constant be 2 times A. Okay, now there's a reason for this. If you don't do this, there's this annoying 1/2 that tracks around the problem. So if you go back to the beginning and call it that, then it's okay. All right, so we'll go from the distance thing. All right, so the square root of x plus c squared plus y squared plus the square root x minus c squared plus y squared has to equal 2a. All right, so you guys don't have to play along at home if you don't want to. I'm just going to develop this equation. Now, for those of you that are algebraically challenged, and you know who you are, these are the kinds of things that you should be doing on your spare time. Like, go back and see if you can recreate what I did. Okay, this one's going to be more complicated because we're going to have a radical, but the strategy with radical equations, folks, is you isolate one of the radicals and then square both sides. So this is going to give us x squared plus 2cx plus c squared plus y squared equals, now I'm going to square that thing out first, okay? X squared minus 2cx plus c squared plus y squared. Then there's a 4a squared, and then there's a minus 4a radical, all that junk. Okay, now a bunch of stuff is going to cancel here, okay? X squared cancels with x squared. C squared cancels with c squared. Y squared cancels with y squared. So what we're left with is that 2cx equals negative 2cx plus 4a squared minus 4a square root of x minus c squared plus y squared. All right, so if I move this to the other side of the equation, I'm going to have 4cx minus 4a squared equals negative 4a radical x minus c squared y squared. And then if I divide everything by 4, I'm going to get cx minus a squared is negative a radical x minus c squared plus y squared. All right, so now I'm going to square both sides again. Cx minus a squared squared, and that's going to equal a squared. Now I'm going to square all that crap out again. Okay. And so this is a to the fourth minus 2a squared cx plus c squared x squared equals a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. Okay, and some stuff will cancel. Again, that will cancel with that. And if I take everything that has an x and a y, like for example, if I move this to the other side of the equation, or better yet, since I only have to move one thing, how about I would move this to that side of the equation and then move this to the other side of the equation. Okay, so when I do that, here's what I'm going to get. A squared minus c squared x squared plus a squared y squared. This equals a to the fourth plus or minus a squared c squared, which is a squared times a squared minus c squared. So if I divide both sides by that number, I'm going to get x squared over a squared plus y squared over a squared minus c squared equals 1. Okay? Okay, now what are you just itching to put underneath the y squared? B squared? Yeah, probably right. Okay. So now what we want to call a squared minus c squared equal to b squared. Okay, so maybe we need to look into this a little bit and draw a picture and see what's going on here. Okay, so my focus was like here and here. Oh, no, not there. That's too far away. Great. Nice little fucking line. Like so. I don't like this either. Oh. Okay, so our ellipse is doing something like this. X and Y. Okay, now these were these two focal points. Okay, and now right there, let's say. Okay, now remember that this was the point A, comma 0, way back up here. I mean, C, what is it? No, I haven't figured that out yet. Okay, so the focus is at C, comma 0. Okay, so this one is at C and 0. Okay, now the sum of these two distances have to equal 2A. Okay. Well, this distance is the same as that distance. So that would imply that this distance from here to here is A, and that distance from there to there is also A. This distance from here to here is C, and this is a right triangle. A is the hypotenuse. A is high on the hypotenuse. Did you guys see that Key and Peele episode? High on the hypotenuse. Okay, so A is the hypotenuse, so that means A is bigger than C. So that means that A squared is bigger than C squared. So we can call B squared this number, A squared minus C squared. Okay, so when we get all down to the result that we want, the equation where the foci are on the x-axis, okay, it's going to be x squared over a squared plus y squared over b squared equals 1. Okay. With the understanding that we all understand that the relationship between these numbers is a squared equals b squared plus c squared. Okay, so when we first start looking at where the focus is, we don't really do this in intermediate algebra. We save this for college algebra and pre-calculus.
Also in
So,
trigonometry.
and maybe there. Okay, so like if I gave you this thing, x squared over 5 plus y squared over 3 equals 1. Let's see if we can figure out where what the value of where the foci are. Okay.
Hey, Bobby.
Yeah.
Real quick though. So earlier on in the problem, we had a to the fourth minus a squared c squared equals a squared minus c squared times x squared plus a squared y squared. What happened to what was on the left side of the equal sign? Or sorry, on your case, I think you had it on the right side, the a squared times a squared minus c squared.
Talking about that piece?
Yeah. Did we divide that through the other side?
I divided both sides of the equation by the whole thing. That's how I got a 1 right there.
Oh, okay. That I did not see that one. And then, okay.
He factors it out so that way it cancels out. So it turns into 1.
Okay. Okay. I got you. Sorry. Just want to double check.
Okay, so 5 is 3 plus c squared. So now we know that c squared equals 2. So c is radical 2. All right. And the focus, because they're on the x-axis, the foci are going to be at the points plus or minus the square root of 2, comma 0. Okay, now, the way that you know what axis the focus is on or parallel to has to do with which of these two numbers that you get presented is bigger. Okay.
The left.
So in this textbook, he gives us equation number 4, where he says, okay, x squared over a squared plus y squared over b squared equals 1, with a being bigger than b being bigger than 0. This is the ellipse where the foci are at plus or minus c, comma 0. Okay, and where c squared is equal to a squared minus b squared. Then in equation number 5, he says if you've got x squared over b squared, y squared over a squared equals 1. Now here, the a is still bigger than the b, still bigger than the 0. Now the foci will be on the y-axis because the underneath guy. But we still have this a squared minus b squared thing. Okay? All right, so we'll do a couple problems here in a second, but there's a room back in, next semester in your multivariable stuff, you take an ellipse, and if you rotate it around the x-axis, you get something called an ellipsoid, And back at Washington, D.C., in the Capitol building, there is a room where the ceiling is all elliptical. Now, if you've ever been down to the Reuben H. Fleet Space Center down in San Diego, and it's like the Space Museum, they have this room with all these really kick-ass things. Like if you've gone into our planetarium, you see that big thing that's doing sand. This thing has got a ton of this stuff, and it's a huge room. It's maybe a couple football fields long. Anyways, they'd have these steps, and then you would stand on this platform, And then they had this thing like here, and then you would, you'd stand up here, and then you talk through this hole. And then my brother Kevin is way on the other side of the room. He walks up and he listens through this hole. What happened is I talk, and this is how it goes with an ellipse, okay? That with an ellipse, anything that you shoot out is going to get redirected back to that guy, okay? That's just kind of how it goes, okay? So here's like, it's kind of, I didn't mean to do the whole thing. Okay, so it's like dit, 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 and then it goes like this, okay, and then the bottom is, dit, 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 dit. Okay, now here's where the foci are. Okay. Now, this is an urban legend, and this is in the U.S. Capitol. Okay. Former President Richard Nixon, he did many things. Some people think he was the worst president ever. Some people think, well, not so fast. But one of the things that he did do was open up China, and, back in the 60s and the 70s, that looked great on paper. Hey, look, if we start relations with China, that's 1 billion people that are going to be buying our shit. That was the logic, Now, of course, it didn't work out that way, we ended up buying all their crap. But in any event, in this room in the U.S. Capitol, the entire room is shaped like an ellipsoid, okay? And during the time when, this is the urban legend, when Nixon was negotiating with the Chinese, they had teams. And so you had the Chinese guys, maybe walking through, let's go check out the Capitol. And what they did is they put a bar right there with a bunch of free booze, who's not going to want some free booze, and so they said, okay, well, go ahead and help yourself to cocktails or whatever, and we'll be back in a moment. We'll go get who you need to meet with. Well, right here you got CIA guys with little recording devices, and these guys are over here talking in Chinese, and these guys are listening to everything they're saying just because of the boom, boom type of thing. Doesn't matter where it goes. Okay, it's gonna go right back to there. Now, is it true? He was called Tricky Dick. Maybe, maybe not. Okay, but anyways, that's a kind of an interesting application. And in this time where we got nothing to do, you know what I'm learning over these last 3 days? It's very hard to find a bike rack to put on the back of your truck.
Oh,
Really?
you bought them all?
They're all on back order.
Yeah.
And so, and this new bike that I got, its tires are too big.
You don't have a pickup truck?
Yeah, I do, but this bike it's a e-mountain bike, and I have a Raptor, and to get the thing up in the Raptor is gonna break my back.
Oh, okay. Because I was gonna say you can do the way we do it, which is basically you put a towel down over the thing and you just wrap it around there.
It's just it's too tall. I'm just gonna wreck my back. Okay, so anyways, now here are some terms, okay, and things for an ellipse. Okay, so the center is the midpoint equals the midpoint between F1 and F2. Hold on one second, guys. I have to shut the gate for the dog goes out.
Brian, did you ever watch the series Monk? Brian?
All right. So the center is the midpoint between the two focal points. Okay, so if this is F2 and that's F1, the center is going to be right there. Okay, so if we want to move the center, move the center to H comma K, then our two equations would be x minus h squared over a squared, y minus k squared over b squared equals 1. And then the other one would be x minus h squared over b squared, y minus k squared over a squared equals 1. And if any of you ever get into teaching or tutoring and you're doing these conic section stuff, it kind of drives you nuts with the some books use different letters and they're inconsistent and whatever. Okay, so now the line through the two focal points is called the semi-major axis. I don't know why someone had to say semi or just major axis.
Hey, Bobby,
Okay.
real quick. Number 2 is B is greater than A, correct? I have this in my notes. I just want to make sure I have it right.
No, A is always bigger than B.
Oh, so 1 and 2. Are you going to show us any examples of where B would be greater than A? Or does that not happen?
Now, what I'm saying here is this.
Hmm.
Of the two numbers that are in the denominator,
Yes.
whatever's bigger, we're going to designate that as A squared.
Okay. Whatever.
It has nothing to do with like, is it ever going to happen? It's just, you know, if I have x squared over 3 plus y squared over 2, A squared is 3. You know, if I've got x squared over 2 plus y squared over 3, A squared is still 3. It's the bigger of the two guys. Okay. So
Gotcha.
the line that goes through the two focal points, this is called the major axis. Okay. The line perpendicular to the major axis through the center, which is HK, is called the minor axis. The semi-minor axis. Okay, more words for us. The points on the ellipse and on the major axis are called vertices in some books. In this book, I believe he does. Okay. So like, let's say I had an ellipse that was more of an up and down ellipse, okay? So then this is going to be the major axis that goes through the focal points. And so these 2 points, which are on this line, these are what we call the vertices. The equation of this guy would be x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay? So the semi-minor axis is going to be that guy right there. I've never heard anybody call these points anything. Okay? And in the exercises, you know, he's got, you know, puzzle problems for you. So let me like do one or two of those here. Let's suppose that we're looking for the ellipse, and our ellipse is going to give you some information here. This ellipse has foci at 0, -1, and 8, -1, and then a vertex at the point 9, -1. Okay. Okay, so let's see here. The foci are at 0, x is 0, y is -1, and then x is 8, y is -1. Okay, so what we're going to have here is a guy that looks like x minus h squared over a squared plus y minus k squared over b squared equal 1. Okay, so the midpoint between these two guys, this would be the point 4, 0. That's the center. It's halfway through both those guys. So it's going to be x minus 4 squared over a squared plus y minus 0 squared over b squared equals 1. Okay, now let's see here. The vertex is at 9, -1. Okay, so here's 9, -1. So what that means is that since that's a vertex, the distance from here to here is a. Okay, and so that means that the number, the a is 5. Okay, so now I've got x minus 4 squared over 25 plus y squared over b squared equals 1. The only thing left to do now is find b. Well, remember, a squared equals b squared plus c squared. So that means that 25 equals b squared plus the c, which was 4 squared, which is 16. So that means that b squared is 9. Okay, and so our x minus 4 squared over 25 plus y squared over 9 equals 1. Okay, now I'm not going to spend any time doing hyperbolas. I'm just going to give you the definitions of these, because the whole point of this is to get it into polar form. Okay, hyperbola. Okay, so the hyperbola is the guy that's going to be opening, you know, up and down, left and right. Okay, so the standard definition is similar to the ellipse one, but the difference is it's instead of the sum of the distances being the same, it's the difference of the distances in magnitude. Okay, so what we get here is the two equations. The one basic one is going to be the x squared over the a squared minus the y squared over the b squared equals 1. Okay, this is a hyperbola that opens side to side. The center right now is 0, 0. Now notice when x is 0, y would be imaginary, right? So that's how you know it doesn't cross the y-axis. So what we've got here is a sideways opening hyperbola that's going like that. Okay. Now, for a hyperbola, the foci we would have set up just as we did before at plus or minus c comma 0. And the working equation here is that c squared is equal to a squared plus b squared. So you see how it's slightly different? Now the second one, if you've got y squared over a squared minus x squared over b squared equals 1. Then the foci, in this case, are going to be on the y-axis. Okay. And again, we have this equation, c squared equals a squared plus b squared. Okay. Okay, now, there's a little bit more that we can say here. Okay. If we were to take this second one, and let's say that we solved it for y, we would end up with y squared equaling a squared x squared over b squared plus 1, or y squared equaling ax over b squared. Okay, so if you solved for y and looked at y, it would be plus or minus a over b x plus 1. And so we see that in the limit, as x goes off to infinity, the y is going to infinity, but it's going there along these lines. And these end up being asymptotes for the hyperbola. Okay? So the way that you learned this probably the first time when you were taking Algebra 2. Okay, so you identify that this is going to be an up and down or a side to side. It's going to be an up and down, right? Okay. So you go on to the y-axis and you find where the a is, and you go a, and then this would be where the b is, and then this would be negative a, negative b. And then you're supposed to draw a box. And then X marks the spot. Okay. Now remember, keep in mind, I realize this is tilted because I'm sitting sideways. This is the point B, comma A, right? So the slope of this line is A over B. So now the thing left to do is to draw the hyperbola. Okay, it does hit that point. So it goes in here like this. And then you do the other way as well. Okay. So for the other guy, where, what one did I just did? For x squared over a squared minus y squared over b squared equals 1. Again, if we were going to draw this, now this is going to be opening sideways. Okay, we find the a, it's underneath the x guy, and then the b is going to be up here, maybe down here, and then we draw a box. And then I would always tell, when I used to teach this class, intermediate algebra all the time, then you say x marks the spot. All right, and it opens sideways, and so it's going to go like this. Maybe I should draw it in red. All the rest of the stuff are just helpers. The red is the hyperbola. So the box, the lines, they're not part of the hyperbola, just the red is. Okay, now once again, this point right here has coordinates a, comma, b. And the slope of this line would be b over x. So this guy has asymptotes plus or minus b over a x. That's generally something we don't include in intermediate algebra. We didn't talk about focus. I really kind of on the fence. So should we do this in pre-calculus even? Because this, in order to get these asymptotes, kind of requires the concept of limit. Okay, so
They had us do this in trig as well.
oh yeah,
Yeah, it was very. I think this was like the most exciting thing I did in that class because everything else was like very annoying.
okay, so let's try this example. So I'm going to try to figure out everything there is to know about this guy. So I've got y squared minus 4x squared minus 2y plus 16x equals 31. All right. Okay, so you see two of the letters being squared and nothing's canceling. So that means that this is either an ellipse or a hyperbola. The reason we know it's a hyperbola is that the signs are different in front of the x squared and the y squared. Okay, so the y squared is going to be the positive thing. So what we're trying to look for is we want to fill in y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, so I'll take our guy, y squared minus 4x squared minus 2y plus 16x equaling 31. And I'm going to reorganize it as y squared minus 2y, and I'm going to complete that square. Then it's going to be minus 4 times x squared plus 4x, and now I'm going to complete that square. And this is all equal to 31 plus whatever I added and whatever I add. Okay, so to complete the square, we need a 1. 1 goes there. To complete the square, we need a 4. So 16 goes there. Negative 16. Okay, because I added negative 4 times 4. Okay, so by design, this goes into y minus 1 squared minus 4 times x plus 2 squared equals 16. So y minus 1 squared over 16 minus x plus 2 squared over 4 equals 1. Now we just, the center h comma k is at the point 1, negative 2. Okay, now the focus, the focal points, this is an up and down hyperbola. So the foci they are going to have the same x coordinate that the center does, but it's going to go from k, and then we're going to go up p and down p from k. Okay, so a squared is 16, b squared is 4. For the hyperbola, the working equation looks like the Pythagorean theorem. So that means it's equal to 20. So c is the square root of 20, which is 2 radical 5. So the foci are going to be at the point 1, comma, negative 2, plus or minus 2 radical 5. All right. Okay, well, you know, pick a few of those out and maybe do some of those. All right, so where we want to...
Real quick, where do you get your 1 and your -2 from? Sorry, I'm a little bit late to this. I'm copying notes down all the time, the entire time you talk. The H and K. Where's the 1?
I completed the square.
Okay.
So that was this step.
Okay, so you have, when you put that 4 in, that was square rooted to get you what the K was? That's why it's, why would it
Yeah,
be
so the H is -2 and the K is 1.
Oh, I got you. Okay, got it. Thank you.
Wait, did I fuck up?
No, 1 second.
Yeah, I did. This is backwards. Oops, someone's calling me.
Yeah, so it's -2, 1.
Yeah. It's getting to be that point of the day where it's time to drink some beers.
Best part of the day, my man.
All right, so the H comma K is -2 and 1. That's what we got. That's the center. The foci, we still have the C is 2 radical 5. That's not changing. So now the foci are going to be at -2 and 1 plus or minus 2 radical 5.
Cool.
Okay. Okay. So I guess the last thing for us to do here is to look at conic sections in polar coordinates. And we are wrapping up our non-chapter 11 stuff at a pretty good time. We're at the end of the 4th week, right? Tomorrow?
Yeah.
Yeah.
We're halfway done. And so I always like to get there like right at week 8, beginning of week 9. So we're doing pretty good. Okay. Now, by the way, when it gets to that stuff, some of the lectures are only going to be an hour long. Like I can't just dump all of that chapter 11 stuff on you because it's just, it takes time for that stuff to sink in. Okay, so here is a result that he puts in a theorem in the book. Okay, and he says, let's let F, this is an alternative way of getting the equations of the conic sections. Okay, let's let F be a fixed point and it's called a focus. All right, and let's let L be a fixed line. which is called a directrix. Okay. Directrix. Okay. And let's let the letter E, not the E to the X thing, be some positive fixed number. It's called eccentricity. Okay. Now what the result says is the set of all points in the plane P that satisfy the distance from P to F divided by the distance from P to L, which is called E, is a conic section. Moreover, number one, if E is a fraction between 0 and 1, we have an ellipse. Number two, if E equals 1, it's a parabola. And number three, if E is bigger than 1, we have a hyperbola. Okay. All right, well, the proof of this, I'm not going to really go through. I'll let you look at it. But in the case when E equals 1, that's the definition of a parabola. Okay. All right. So what he does here in the textbook, he ends up doing it like this. Okay. He's got his y-axis here, and then here's his x-axis, and he's drawn it like this. Okay. And this is the line x equals d. So this is some d right there. Okay. And so he's looking at the distance from the focus. All of these things have a focus. So in this case, well, he didn't even draw. Yeah, he did draw an x-axis. So he puts the focus on the y-axis. Okay. And then he starts calling this distance r. And then he has this distance right there. Okay. In any event, he does a bunch of stuff. And let me show you where he gets to. Okay.
Professor, real quick,
yeah.
real quick, so the distance between the focus and the vertex isn't it the same from the vertex to the datrix?
The distance from the point to the focus.
Yeah, from the focus to the vertex. The distance between that is the same as the distance between the vertex and the datrix, right? The
Directrix.
the direct. Yeah, thank you.
Yeah. Okay. So he goes through some cases here, and here's how the polar stuff comes in. This is where the r and the theta come in.
Oh, okay.
Okay. So what he does here is he says, okay, this is the point P, that's the focus F, and he says, all right, so the distance here from P to F is equal to R, and the distance from P to L is going to be this distance here, which is going to be the D number. Where did I go here? Okay, it's going to be the D number, and then I got to take away this much, and there's where he gets R cosine theta. Okay, then he does the division thing. He sets PF over PL to equal this eccentricity, and what he arrives at is this thing here, equals E times the D minus R cosine theta. Okay. Okay, then he squares both sides of this equation, and he does a whole bunch of stuff, and he gets to this spot here. X plus E squared D all over 1 minus E squared plus Y squared over 1 minus E squared equals E squared D squared divided by 1 minus E squared squared. Okay. All right, now he's characterizing these guys. So after you square both sides and then use all of your conversion equations, this is what you end up with. Okay. Now we're not considering that E is equal to 1. We've already addressed that. Okay, now notice that this is always positive because this is E D over 1 minus E squared squared. Okay, so this thing will, if E is a number that is less than 1, but bigger than 0, then this would be a positive, meaning you have a positive in here. So if E is between 0 and 1, we have an ellipse. Okay. Now, if E is bigger than 1, 1 minus E squared would be negative, and so we'd have a negative sign in between those two, hyperbola. Okay. Now, I'll let you guys study and read up on that, you know. But when we eventually get this thing into standard form, okay, like he calls the H equal to negative E squared D 1 minus E squared. And the A squared, well, that's the thing. It would be 1 over this E squared D squared, 1 minus E squared squared. We would divide both sides by that.
Hey, Bobby, real quick. I noticed that you have H equals minus E squared D. It's not E squared D. Oh, it's coming from the X. Sorry. I just wanted to double check that before we move too far.
Yeah, actually, the A squared is just that thing. I don't have to flip it over because I'm dividing through by it. Okay. And the B squared is going to be the E squared D squared all over the 1 minus the E squared squared. Okay, so he's saying that A squared, this is not right. This guy doesn't have the, he just has 1 minus E squared. Okay. So from this, he continues through and ends up with this C over A. Okay, now A was the bigger of the two numbers and C was the distance from the focus. Okay, so this is kind of an important thing to recognize. So if you're given this kind of conic section, like let's say x squared plus 2y squared minus 3y plus x equals 5 or something like that, and you want to find the eccentricity, you would put it in standard form and then figure out what those two numbers are. Okay, now the whole point of all of this is when we put these conics in polar form, they end up looking kind of interesting. So conics in polar form. All right, so if you kind of go back up here, I kind of had already had something like this starting off. Okay, so here's what we have. Polar forms in the form of this: ED divided by 1 plus or minus E cosine theta, or R equaling ED divided by 1 plus or minus sine theta, E sine theta. Okay. These are both conic sections. Okay, now the special thing about the E number. Okay, so the eccentricity is telling us like what the orbit is like. So like, for example, an orbit that is kind of maybe like the Earth's, which is semi, it's not circular, none of the orbits are. In this case, this might be like 0.2 or something like that, as opposed to like Halley's Comet thing, where this eccentricity is going to be pushing close to 1, like maybe 0.92. Okay. And so when you get these things in the standard form, you read this number off, and that tells you if you have what kind of conic section that you have. Okay. And he talks about some other things, orbital mechanics. He's got some Kepler's laws in there. I'm not going to go there with you guys, Kepler's law. But if you want to, knock yourself out. All right. Stop testing. There we go. Oops. All righty, folks. So I will be looking at your your exams, maybe starting Saturday. I'm sure there's people that still can't figure out how to turn things in, and so I'm getting messages. So I'll look at them over the weekend, and then what I'll do is I'll take pictures of that elliptic integral. And this is one of the bummer things. When my truck got broken into, and in my backpack, I had this one file that had these 2 textbooks that I'm always digging in, and it had these 2 journals that had articles that I really, and a few other like things, and then anyway, gone. But I still have my elliptic integral thing, so I'll put that in an announcement, or somehow figure out a way to take a picture of it, and then you can work through it at your leisure. I got this out of it was an article in Mathematics Magazine about elliptic curves and what the hell they are, and so this is how they get there. All right, elliptic curves are very hot area of research in mathematics these days. Okay.
Okay,
So-
Doug. Thanks, man.
So now let's get down to business here. Does anybody know anybody who's trying to sell a bike rack?
Usually bike shops like here there's
Everybody's out of them.
all
I'm going to do one more look on OfferUp, and then I think I'm going to just suck it up. There's one left on Amazon. I can't just use any bike rack because my tires are like 2.8 inches.
Have you tried on wish.com?
Okay, I'll try there too. I'll look
Yeah,
there.
that one's pretty good. Usually I bought a lot of weird stuff on there.
Okay. That sounds good.
My dad and I, we bought an e-bike, and the tire is like 3.5. So we bought a bike rack from Dick's Sporting Goods, but it didn't fit the e-bike. And then we were struggling to find one because all the shops are out of them, and
Yeah.
Amazon's out of them, or the shipping is like not for another month. But we did find them at REI, and the shipping at REI is a lot faster than Amazon. So you have to call REI and ask if they have it in stock. And if not, then you can just do shipping, and it's like a week, which is a lot better than Amazon, I think.
Okay, I'll look at REI.
I recommend getting looking at the brand Kuat, Kuat, because they actually fit the e-bikes, like the tires and stuff. And they're
That's
very,
exactly the rack I'm looking at, the Kuat NV 2.0.
yeah, that's the one we have. We have
Yep.
the one, not the one with the orange and black, but the all black one.
Uh-huh.
Yeah, my dad wanted the orange one, but they were out. So we just took the black one.
How much was it? Do you remember? Like $689?
Yeah, it's like $6.89 at REI.
Yeah, that's all. Okay. Thanks.
Mm.
Okay. Let's see here. Another Coast employee tested positive.
Oh,
Last time they were on campus was May 15th, so they're fine. Okay, here's a good one. So yeah, I told you my neighbor, next door neighbor, tested positive, and his girlfriend who lives there, she's tested negative twice, I think.
really?
So I was questioning whether or not Russ even had this at all. It's like Brian was saying, where you just take any test and don't do anything with it and send it in, it'll come back positive.
Well, the other thing is like the immune sometimes have is just high enough where it just, you can probably lick their face and they'll be okay. When I felt like I said, like when I felt like I was dying when I had it, literally the first 2 days I felt like I couldn't breathe, I couldn't get up the stairs, I ended up sleeping on the couch. I had fever, cold sweat. I immediately lost my voice within maybe 4 or 5 hours, and I didn't get the cough as much, but I just did. I got like a small sores all over my mouth, because I usually get those with fevers when I always get fevers. But the shallow breathing was just like unbearable, especially when you're like sleeping. I'm one of those that sleeps on my stomach, so it was like, what the thing that I could have done was just like literally just have the air conditioner near me.
How long did you have for, Eduardo?
I felt bad. Well, I felt bad for like a whole 2 weeks, and then the third week class started, and I was just starting to feel better where I could drive.
Yeah.
Oh,
this was in January.
Huh?
Oh, that's when Bobby had it, right, man? January. That's when everybody I knew had it.
Everybody in our class had something.
Yeah.
When we
It
were
was all around the same time. We all had it.
Yeah. Well, I'm glad we're closing up everything right now in July, not January when everyone got sick. That would be the dumb time to close stuff up.
Yeah, Exactly.
Yeah, man. Well, I'm glad you guys are both well, but yeah, I knew a bunch of people got crazy sick with some weird cold cough thing in January, but man, there are enough people who believe that that can't be that because the news said it's not that till, they recently retracted that, but I had a buddy I was arguing with, the doctor, who has a crazy cough. He's had one since January, and he also was sick for a long period of time. And he said it's impossible because we only got coronavirus starting March 14th or whatever the news told us that we got it. So, man, it's, for me, like I said, I don't really argue with people about
That's
this
the first thing they saw.
Yeah, that's the first thing.
I have a friend who travels to China regularly on business.
Yeah.
Okay. And he very easily back in October or November could have caught back there, got back on the plane, came home.
Yeah. Tons of people do it every day. It's a very normal trip. Like, I think people probably got sick in December, January, all of that time, but
I know it was in December because it was right after my wife went to her company's Christmas parties and Thanksgivings.
oh, okay.
Whatever that Christmas holiday parties that she went to, because it was just people flying back from wherever they were, right? And of course, you hug and you share food and you're near each other and stuff
You're
like that.
kissing everyone, man. I kiss every single person I see. That was big. But I do have to bounce.
I remember getting.
I think
better.
I was sick. I think I was sick before Kobe died.
Oh wow. Okay, that was mid-January.
But I think I was sick before we came back to school.
Oh, okay. So probably second.
And then I remember Eduardo from day one, like being all jacked up.
Yeah, I kind of remember.
And there was this other girl that was all messed up too.
Yeah.
And then the two of us thought that it was the building and the allergies that we have.
Yeah.
But for her, it wasn't. I guess she said, no, this is different. Mine stopped.
Yeah.
I tell you, man, not being in that building every day is certainly nice.
It is. We're back, right? Speaking of which,
Yeah.
I got to ask you, not today, but I have had weird lower back pain. I'm curious what you do to take care of it, but I got to go out for a walk. Justin asked if we've got a test next week. I assume, I told everybody, yeah, because we got to have one almost every week, right?
Yeah, we're going to have a test every week.
Yeah.
It's not really a test. It's more like I just do these problems. Speaking of the problems, so were you guys able to solve number 9?
Let's see, 9. I think 9 was one of the ones that I was able to figure out.
Does it look like? Can you see that?
Yeah, that's how. Yeah,
But
Out of it.
that's something.
And I
What
read
I
it.
got.
Does your answer look like that logarithm crap that I have?
Yeah.
Yeah.
Oh, sorry.
No, I like your background, Gopal. It's nice.
Thank you.
I'm gonna bounce though. I'll see you guys tomorrow. I just been trying to get to the sun before it sets totally. So I'll
That
tomorrow.
algorithm that you did, when I tried to do it, I factored out the 2 and it came out to being 2. Let me see where my answer was.
Yeah, I got log mod like